Welcome to Spring LIB.
So this is the breakdown of water into hydrogen and oxygen, and we are given a time and we are given a current, and from there we can determine how much hydrogen and oxygen are produced. And so when we are going from a time and a current to how much the quantity of something is produced, we can go from time to charge using current equals charge over time. We then use the Faraday constant to tell us how many electrons were transferred. Then we can use the mole ratio of how many electrons are in the equation to how many moles of hydrogen and oxygen are in the equation. That will give us the quantity of hydrogen and oxygen that's produced. And then we can just use the ideal gas law to get the volume. So we're just basically, instead of calculating mass, we're calculating volume. So for moles of electrons, we have to look at changes in oxidation state and how the equation is balanced. So oxygen is going from -2 to 0, so that means 2 electrons were transferred. So we just want to double check with hydrogen. We have 2 hydrogens going from +1 to 0, so that matches 2 electrons. So now I'm given a time, it's 15 minutes. I have to convert to seconds because current is given in amps, and amps is coulombs per second. So take care of that here. Now the seconds cancel, and I'm left with how many coulombs. So that's the total charge that's been transferred. Now I want to figure out how many electrons that is. And so that's going to be Faraday's constant. So now I have 2 steps. I have to figure out how many moles of hydrogen were produced based on that, how many electrons were transferred. So I need the mole ratio of hydrogen to electrons, and that's going to be 2 to 2 or 1 to 1. And then for oxygen, it's just going to be 1 to 2, just based on the coefficients in the equation. So for H2, I get 0.0233 moles. For O2, I get 0.117 moles. And so since oxygen is just half of hydrogen, I'm just going to do the equation, rearranging the ideal gas law, solving for volume. If I do it for hydrogen, I can just divide that value in half for oxygen, and these are going to be the volumes for hydrogen and oxygen.